Okay, good morning class. So today we're looking at the May-June 2021 Mathematics Paper 2. From the last video we stopped at 5.2. Okay, so we will be continuing from that point onwards. Okay, so we stopped at 5.2, so we must carry on at 5.3 now. So in question 5.3, the question says, determine the general solution of cos 4x times cos x plus sin x plus 4x. So hang on, where are you guys going?
Because we're the other grade outside.
Okay, so the general solution, so we need to reduce this cos of 4x, cos x, sin x and sin 4x. So we know that cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. Okay? So if we say alpha is 4x and beta is x, then this would have simply been cos of 4x minus x equals negative 0,7. So 4x minus x is 3x, of course, so it's cos 3x is equal to negative 0,7. That now gives us a reference angle of 3x equals arc cos of 0.7 gives us 45,570. So that is 45,570 degrees. So the question that comes to mind is in which quadrant is cos negative? Cos is negative in quadrant 2 and 3. I know some of you would say it's going to be negative 180 plus 5,57 and 180 minus 45,57. Now I tend to work with the positive angles, okay? So in quadrant 2 it's going to be 3x is equal to 45. Now it's 180 minus 45,57 plus k times 360, because of the period on the cos graph is 360, or 3x is equal to, for quadrant 3, is going to be 180 plus 45,57 plus k times 360. Okay? I erased this earlier on, but I didn't write it in. 180 minus 45,57. Okay? So what we do is we say 180 minus 45,57 and then divide it by 3 throughout. So it's 180 minus that answer divided by 3 gives you 44,81. Okay? So it's 44,81 plus k times 120 degrees, or 180 plus 45,57 divided by 3, an answer of 75,19. So x is equal to 75,19 plus k times 120 degrees, where k is an element of integers. Okay. Any confusion here? No? So we're going to 5.4. Okay, 5.4, where they ask you to prove the identity. So I need some space. I'm going to take this leave you some of you. Okay, so in question 5.4 they asked you to prove the identity. So, to prove the identity is going to be a left and right hand side story. As you can see, the more complex side is the right hand side. So we start off with the right hand side and I do my first simplification in the sum on the left hand side. Okay, so if I look at the sum here, I can see that what is common here? Okay, here we got sine x cos x. That reminds me of sine 2 alpha, which is sine alpha, 2 sine alpha cos alpha. Okay, so this part we have, and if you consider the 2, we have that whole story. So in other words, I have sine 4x times cos 2x minus, now remember 2 sine x cos x can be written as sine 2x. As I showed you now. So that's going to be sine 2x cos 4x over tan 2x. Okay. So we got sine alpha cos beta minus sine beta cos alpha. That is your sine compound angle. If there's a plus here, you will have a plus in the bracket. So it's going to be sine alpha, which is 4x, minus your beta, which is 2x, and this is all over tan of 2x. Okay? But tan of 2x, tan is the same as sine over cos. So in other words, tan 2x can be written as sine 2x over cos 2x. This line here means divide. So it's going to be sine 4x minus 2x is 2x divided by sine 2x over cos 2x. Naturally that's over 1. Change this to multiplication at tumble and times. So it's going to become sine 2x over 1 multiplied by cos 2x over sine 2x. So what I can do at this point is I can cancel the sine 2x's, sine 2x. Then I'm left with cos 2x. But if I do the comparison for the left and right hand side story, I haven't done the job as yet. But what you should note is that cos 2x can be written as 1 of 3. Okay? Cos 2x, cos 2 alpha can be written in, and is on your formula sheet. 2 cos squared alpha minus 1, 1 minus 2 sine squared alpha, and cos squared alpha minus sine squared alpha. Okay. And the one I'm looking for in particular to link in with that one there is the last one. So I can say which is now equal to cos squared x minus sine squared x, which is in fact equal to the right hand side. Okay, any confusion here? Fairly simple, no? Definitely we'll get a sum like this in your exam. Okay? So please know how to do this. Okay? Question 6 is a question that many students just leave out. I shouldn't be leaving out this question here. So we are told that in the diagram below, the graph of f of x equals, just take this out. In the diagram below, the graph of f of x equals cos 2x. Okay, so without looking at the graph, we know that the cos 2x graph does the following. If there's 2x, that's going to be 180, 1 and minus 1. This is the cos of x graph. Then the negative sign of x graph, we know the graph is going to be reflected in the x-axis. That is what the negative sin x graph is going to look like. Are drawn for the interval 0 to negative 180. So, negative 180 to 180. So that is the cos graph. However, the sine graph will be cut there and we continue that side. So that's negative 180 to 180, which does confirm that graph there, which I have, which is this part of the graph only, and this whole graph there as indicated. Okay. It's important to know how these graphs are drawn so that when we interpret these graphs, it's just going to become so much easier. Okay. Then we are told that A and B are points of intersection of F and G. The points of intersection, the graphs are equal at those points. Okay, there's another point of intersection. If the question is how many solutions there are from negative 180 to 180, the answer would have been 3 in this case. As you can see, the graph is cutting itself in this given interval at 3 points. Okay. First question, let's go. We are told in 6.1. In question 6.1, we are told, without using a calculator, determine the values of x for which cos 2x equals negative sin x in the interval x is an element of negative 180 to 180, which means to say is the interval given, or the graph is drawn in. So if you're looking at the cos of 2x graph, that is the f of x graph. Cos 2x is the f of x, and negative sin x is the g of x graph. So the variation on this, they're going to say determine the values for x for which f of x, in other words, is equal to g of x. It's the same thing. Okay? So what we need to do is, it's not going to be say for us to say for 6 marks, we're going to guess what A and B is. Of course, there's some calculation involved there. So what do I do is, when the two graphs are set equal to each other, we must go into a general solution again. So we take that over the equal sign. It now becomes cos 2x plus sin x equals 0. But we say, okay, there's no way I can factorize or do anything with regards to cos 2x here. So remember, as I wrote it down earlier on, that cos of 2x can be written as 1 of 3. It can be written as cos squared x minus sin squared x. This is also on your formula sheet. 2 cos squared x minus 1 and 1 minus 2 sin squared x. But you say, okay, here is a sign here. Can you see that? So if I'm going to write that cos squared x minus sin squared x, is not going to help the course, because I wouldn't be able to factorize it either, or simplify it. If I'm going to replace it with 2 cos squared x minus 1, you could actually choose any one of these 3. Any 3 will work. Okay? But if you choose the first one, you'd have to change cos squared x to 1 minus sin squared x to form a trinomial. If you had chosen this one here, again, cos squared x is going to be written as 1 minus sin squared x. It won't be wrong. It's just going to take you another step in pursuit of calculating the value for x. Does it make sense? The one that needed to be chosen, well, the easiest one at this point is the last one. Okay, so I'm going to choose cos 2x to be 1 minus sin squared x. Okay, and again, why do I do that? So that I can form a trinomial b. Okay, so I said I'm going to choose 1 minus 2 sin squared x plus sin x. Another thing is, how did I know that is correct? I just look here. Okay. So I take that, put it in a standard form. So it's going to be 2 sin squared x plus sin x minus plus 1 equals 0. This is now a trinomial case. Okay? One of two things I can do here, or three things. I can either factorize using trinomial rules that was taught to us in grade 9. Otherwise, you can use the quadratic formula, or I can use the latest invention, the calculator. Program it, so you're going to go with coefficients of x squared, which is negative. So in other words, what you should see is negative 2. Whenever I see an x, I put the sign, I put the x. So it's negative 2x plus x plus 1. Can you see that trinomial there? You see that, people, the link between the two equations. Whenever I saw a sign, I put a x. So it's negative 2x squared plus x plus 1. So I punch that in the calculator for your quadratic formula. Your a is negative 2, your b is 1, and your c is 1. Okay? So in other words, x is equal to 1, but what is x? Sine. So sine x is equal to 1, or sine x is equal to negative half. Okay. So you say, okay, do we stop here now? So the answer is of course not. Okay. So what do we do for a sine x equal to 1? We take it to the, okay, just put it at the bottom. We'll take it to the graph. So it's simply the sine graph. That's that thing. Where sine of x equal to 1. It's at 90. This is sine x here. It's 360. So it's at 90. So x equal to 90 plus k times 360. Yes. Or, on the other hand, I know it's a restricted domain. It's just going to make life a bit easier for us. From here we could have read easily. Sine is going to be equal to 90, which is here. And we're going to say 90 minus 360 is negative 270, which is outside this given domain here. Okay? So x will only be 90 for that branch. Okay? So for the side here, x is equal to 90 degrees. Or on the other hand, my reference angle then, we got sine of x equal to negative half. So my reference, I got arc sine of half. I drop the negatives, I use positive angles. He's going to give you 30 degrees. That's also coming from the special angles. So the question we should ask ourselves, in which quadrant is sine? Negative. And sine is negative in quadrant 3 and 4. So that would simply be, for quadrant 3, is going to be sine, sorry, not sine, but x is equal to 180 plus 30, which is 210 degrees plus k times 360. Or, in quadrant 4 is 360 minus 30 degrees. Is 330 degrees plus k times 360. But remember, we must give it within the given interval. Okay? So x equal to, I'll put 0 through here. I'm going to get 210 degrees, which is outside the given domain. So we replace k with a negative 1. So it's 210 degrees minus 360. Whoops. 210 minus 360 gives us negative 150. So if we look at the graph itself, does it make sense that negative 150 would lie here? Absolutely. Remember, this is negative 90. Okay? So yes, that is negative 150. Or, if I'm going to put minus 2 in here, it's going to be off the graph. If I put 0 through here, it's going to give me 330, which is outside. Put negative 1 where I see k, I then get x is equal to negative 30 degrees, which is this point here. Now coming back to the question. The question says, without using calculator, determine the value for x for each. So in other words, I must represent all three. Okay, if they ask you to determine the coordinates of A and B, then I would have put negative 150 into the sine x graph. Okay, and I would have gotten the corresponding y value, which I think it's a half. Okay, it would be negative sine of negative 150, which gives you a half, or you had got negative 30, which would also give you a half for the corresponding y value of B. But since the question says the values for x, this is what they are looking for. Okay. So here's the highlight. These are the answers they're looking for. That there, that, and that solution. Those are the solutions they are actually looking for. Okay. People, general solution, definite question in your exam, a minimum of 6 marks in every paper 2 weeks. Okay, so know how to do these things. Okay. Then in question 6.2, so what I'm going to do is I'm going to write this information. Okay, I got it there on the diagram so that I can keep the question in focus. Okay. Let me take this off here. I can keep the graph in focus. Okay. So in question 6.2.1, the question says, use the graph above to answer the following questions. How many degrees apart are points A and B from each other? So as I've indicated already, this is negative 150. So from 150 to 100, from negative 152 to negative 30 is 120 degrees. So they are 120 degrees apart. Okay? I think that's fairly simple. No reason to labor that point. Take this off. It's 120. Then in question 6.2.2. In question 6.2.2 we are told for which, or asked for which values of x in the given interval will f prime x times g prime x be greater than 0. So you'll say, but this is not paper 1 question because it's dealing with derivatives. But what is a derivative to us? The derivative is our general gradient anywhere along the curve. The derivative is a general gradient anywhere along the curve. So if you multiply f of x by g of x, okay? If you multiply if you want something to be greater than 0, that basically means to say the number must be positive, in other words. So under what condition when we multiply two numbers is something positive? If both is positive or both is negative. That's the only time you'll get a positive solution. Not so. So if you're considering f to be positive, then g must also be positive. So positive times a positive is positive. Otherwise, if f, the gradient of f is negative, the gradient of G has to be negative at the same time for a negative times a negative to be a positive. Okay. So importantly at this point here, for f of x, this, the gradient here from negative 180 to 90 in the negative is negative. Can you see that? The graph is decreasing as x increases. So that is negative, a negative gradient. Okay? What do you notice here? Gradient is positive. Because as x increases, the graph is increasing. So that gradient is positive. Here, the gradient is negative. The graph is decreasing. So the gradient is negative from 0 to 90 degrees. What do you notice here? The derivative of f of x is greater than 0. The gradient is positive. This here, that is f dash x is less than negative, and less than 0. So let's look at the g of x graph. The g of x graph, here the gradient is positive, the graphic that is increasing. Here, the gradient is decreasing. Here, increasing. Does it make sense? So remember, we are coming to the point where both gradients must either be positive or both gradients must be negative. From negative 180, what do you notice? One is increasing, one is decreasing. Can you see here? One is increasing, one is decreasing. So that is increasing till negative 90, and this is decreasing till negative 90. Not so? So both is decreasing. So that's not what I want. Okay? So what do you notice? From negative 90, one is increasing till where? The other one is decreasing far past that. Not so? Far past 0. So that is still not what I'm looking for. Not so? However, on the other side of 0, if it's decreasing and g of x is decreasing. Is that not what I'm looking for? Not so? So, both is decreasing for x is greater than 0 but less than 90 degrees. Alright? Or, what do we notice here? Both is increasing, and that's what I'm also interested in. Not so? So I say, or x is greater than 90 but less than 180. You could have represented, that's one way of doing it. Or we can say the graphs are satisfying the given condition when x is greater than 0 but less than 180, but x is just not equal to 90. Because at 90 degrees, the graph, both graphs are neither increasing nor decreasing at that point. Alright? Does it make sense? Any confusion? Let's take this out here. I think there's one more question pertaining to this graph here. Question 6.2.3. Question 6.2.3. The question says, determine the value of k for which determine the value for k for which will have no solutions. So if you look at this graph here, okay, what I notice is that this is the graph of f of x. In other words, the f of x graph is moving 3 units up. Not so. So if this graph moves 3 units up, okay, currently there's a 1 here. So let me just redraw the graph rather. So what happens is f of x plus 3. So it's the cost graph. Let me make it a bit smaller. The cost graph. So if this is 1 and minus 1. Okay. I'm going to move this graph 3 units up. Okay. Then this is going to go to 4. Okay, this is not a good representation of what I want to show you. So I'm just going to draw a grid quickly. Then I'll show you a better representation of what's happening. Okay. I'm just going to pause the video quickly. Okay, so if I look at the cos 2x graph at a given interval, okay, then the graph did this. Let me just get this right, otherwise I must redraw again. It's going to come through there, there. Okay, so this was the basic graph given to us. Okay, that was the cos 2x graph. Alright, let's take this out here. So that was a basic graph. So what happened to the g of x or the f of x? F of x. I said g, sorry. So the f of x graph, that was the basic graph. But what happened to the cos of x graph, 2x graph? Shift 3 units up. Okay, so it's 1, 2, 3 units. Not so. So the question says determine the values of k for which will have no solution. So as it stands there, how many solutions does it have? How many solutions does this graph have? 1 solution. You all agree with that? What does solutions mean? Where it cuts the x-axis. How many points does this cut the x-axis? No points. So how many solutions are there? 0. There's no solutions as it stands. Not so. So the k value, as we know, is a y value. Not so. So for this to have a solution, the graph must be there. Okay? At k is equal to 0 there. Okay. So currently, at this point, my k value is at this point. Use the other color. So at this point, your k value is 4, and this k value is 2. Not so. So in other words, as long as k, so as we said, this is a y value. Currently, if k is equal to 4, then it will cut here at this point, and if k is equal to 2, it will cut at those points. Okay, so anywhere between these values of 2 and 4, it will have roots, in other words. Will have solutions, okay? Whereas k has to be greater than 4, or k has to be less than 2. Okay? So k must be greater than 4. And k is less than 2. See, how else can I explain this? Okay? Tell the value of k for which. So, say you got 4. Okay, and I put 4 in here. So I'll have cos 2x plus 3 equals 4. So better get over the equal sign. So cos 2x is equal to 1. If I look at cos of 2x equal to 1, is cos of 2x equal to 1? Yes. So it will have roots there. Can you see that? Otherwise, on the other end, if we had cos of 2x plus 3 equals 2. Now take that over the equal sign. Now we'll have cos of 2x equal to negative 1. And yes, where is cos 2x equal to negative 1? There. And there. And definitely has roots. So if you choose a value that is greater than 4, or a value that's less than 2, then the graph won't have any roots. Which means to say it will not cut the axis, the x-axis. People enjoy the rest of your day? Okay, at this point, the class is left. So I was thinking about the solution here, and I was sure some of them were confused with regards to that explanation. So what I'm going to do is I'm going to look at a different angle now and try to explain from a different viewpoint. Okay. Let's say the cos 2x graph, which is the f of x graph, which is the graph drawn here, okay, is equal to k of x minus 3. Okay. I think this will be a bit better to understand. So if you got f of x graph is equal to k minus, remember this is a y value, né? It's a y value. So currently, what do you notice? How many roots are there? Currently, there's more than one root. Not so? And as long as this f of x graph, there it has roots, there it has roots, and there it has roots. If this graph had moved up, further up, no roots. The graph had moved, remember roots? No roots. Okay? Roots mean to say where it cuts the x-axis. So, that is the graph, let's remember. So, under what condition or at which points will the graph have roots? It will have roots as long as the graph is moving between these values. Can you see it will have roots? And what are the significant values there? Firstly, we'll have this value coming through here at the y equals 1. Let's say the curve, the equation of that line, and that line is y is equal to negative 1. Okay? So we say, okay, but y is not y in this case. Y is actually k minus 3. So in other words, k minus 3 is equal to 1, or k minus 3 is equal to negative 1. Right? So in other words, k is equal to 1 minus 3, which is 1 plus 3, sorry. 1 plus 3, which is 4, or k is equal to negative 1 plus 3, which is 2. Okay? But we need to know that anywhere between that values, it will have roots. So when will it not have roots? If this graph actually moves beyond that point. In other words, it is where k, just check here, k plus k minus 3 has to be greater than 1. It has to be more than 1. Or it is where k minus 3 is less than negative 1. K minus 3 is less than negative 1. So in other words, this here should be k minus 3 is more than 1 so k is greater than 4. Or on the other hand, k minus 3 is less than negative 1, so k is less than 2. So either k has to be more than 4, but k has to be also, or k has to be less than 2. Okay, I hope you understand this point. Okay. Now we're going to question 7. Okay, let's take this up a bit. We have space. Yes, we have. So in question 7 we are told, this is also a poorly answered question normally in the exam. This is your sine, cos and area rule. You must spend time on this and master it before the exam, your final exams, so that we can get these marks, people. Okay, so we are told in question 7 that points points B, C and E lies in the same horizontal plane. So when we see the shaded region here, I always assume, or the learners see it as if it's on the ground. Okay, in the same horizontal plane means to say it's in the same, it's all on the ground basically. Okay, so A, B, C, D. Remember, this is on the ground and it's always shaded, or often shaded. Then we are told that A, B, C, D is a rectangle. So if this is a rectangle, all these angles are 90 and that is equal and so on. Okay? Rectangular piece of board. CDE is a triangular piece. CDE is a triangular piece. As you can see, it's 90 degrees, so we can apply the theorem of Pythagoras in there, or I can apply the standard or the basic sine, cos and tan ratios there. At the right angle at C, then we are told that each piece of board is placed perpendicular to the horizontal plane, which now gives me that the horizontal is, or the horizontal plane will always be perpendicular to the vertical plane. Okay, perpendicular to the horizontal plane and joining the line along this line DC, as shown in the diagram. The question says the angle of elevation from E. Let's just take this off here. The angle of elevation of E to D is x. So this angle is x here. Right? And BEC is 2x. And EBC is 30 degrees. Okay, so there we got 2x. If needed, we can calculate this angle here. Okay? We can go with the fact that it's going to be sum of triangles. Okay? So everything that is given to us, or given in the introduction, is in fact in the diagram. So let's look here. So in question 7.1, they ask you to show that DC is going to be BC over 4 cos 2x. So if you're looking at DC, it's going to be DC is going to be this length. If you're going to look at cos 2x, of course, we need to bring that into play here as well. Why that one then? Because that's basically the link between the two triangles. Okay? So I set it up as starting off by saying in triangle, since there's more than one triangle here, DC. Do I have to say that? No, there's no marks allocated for that. Okay, so if you don't want to write that in, no problem. So you remember that's going to be DC, which is opposite, and adjacent. So which trigonometric function uses opposite and adjacent? Tan. So we say tan of x equals opposite, which is DC, over adjacent, which is CE. Right, so what do they want? They want DC as the subject of the formula. Not so. So what I'm going to do is, I'm going to make DC the subject of the formula. So DC times 1 is DC, so it's CE tan X. Okay, now this becomes equation 1. So now we say, okay, in this other equation, in triangle BCE, in this triangle, okay, is a BC, which we need to pick up there. So I can say BC over sine 2x. We must use CE. So it's going to be CE over sine of 30 degrees. Remember sine of the angle over that length and sine of the angle over that length. Okay. So we are applying the sine rule here. Sine. So we say sine of 2x over BC is equal to sine 30 degrees over CE. But what I'm going to do is I'm going to make CE the subject of the formula so that I can sub it back into equation 1. Okay? So let's go with that. So cross multiply. So that will be CE sine 2x is equal to BC sine of 30 degrees is equal to that is your special angle. So CE is going to be a half BC. This is what that is equal to, no? Half BC. Since I'm dividing by sine 2x, we'll go to the denominator as sine 2x. This equation 2. So what do I do now? I'm going to substitute equation 2 into equation 1. So if I see a CE, I now replace it with that story. Not so? Let's go with that now. We can conclude therefore. Let's pull this down a bit. Therefore, DC is equal to CE is now BC over 2 sine 2x. That is CE. Times tan of x, which must also come in here. Okay? But what is tan? Tan of x is going to be sine x over cos x. Okay, I'll do it in the next step. Okay. I know I'm doing many times a lot of unnecessary steps, but I do it so that the average 2-weeker learner can follow what I'm doing. Okay, it can make sense to them. Because I know even on the answer book, the solutions in the answer book, sorry, they're given you so little space. It could be done in a shorter space of steps or less steps, but as I said, I'm doing more steps so that the weaker learner, we don't lose them. Okay, so they could also follow. So we're going to replace tan of x with sine of x over cos of x, and sine 2x can be written as 2 sine x cos x. So it's going to be BC times sine x over cos x. So this is your tan. That is your tan. Sine x over cos x. Okay? Then you got the 2, and sine 2x can be written as 2 sine x cos x. Okay, 2 sine x cos x. So what happens now is that sine x cancels sine x. So in turn we are left with BC over 2 times 2 of course is 4, cos times cos is cos squared x. Okay. So which now we have proven what they wanted us to prove, that DC is equal to BC over 4 cos squared x. Very important to note at this point is that this is show that question. So do not write that down or do not use that in pursuit of proving that. Okay, as you could see what I did in this example, or in the sum, I've proven it. Okay, I've ended off with what we were required to show. Okay, so I know many learners lose the mark on prove that to show that. Okay, well, sometimes they write too little on that question, and then the examiners assume that they are guessing the answer, because as you can see the answer is given. So the examiner assumed that the learner is guessing the answer because the answer was given. Okay. So when it comes to show that or prove that question, rather write a little more than what you normally do. Okay, in terms of, as you could see what that did. Okay, but I think I just wrote over the top too much. Okay. But let's look at question 7.2. We are told that if x is 30 degrees, okay, so that means to say that this could be calculated. No? That could be simplified in terms of BC. Okay. The question says, show that, let's change the color here, show that the area of triangle, show that the area of, not triangle, sorry, A, B, C, D is given as that. This is again to show that question or prove that. So again, I do not use this. Okay, I must just end off for that. So how do we calculate the area of a rectangle? Area is equal to length times breadth. In this case, it's going to be, remember they worked with BC and they worked with, so they got AB in the proof, so I'll speak that up. So it's going to be, so in other words, it's going to be AB times BC. Okay. AB times BC. Or, because they got DC here, I'm going to rather say DC. I could have gone with AB and then say at this point already that they are equal. Okay, but it's not to complicate things. So it's going to be DC is times BC. That means the length times breadth. Okay. So if you're looking at BC, so I can work out what DC. DC is going to be BC over 4 cos squared 30 degrees. Now BC over, now cos of 30 comes from the special triangle 1 to root 3. Cos of 30 is root 3 over 2. So it's 4 times root 3 over 2 squared. So in other words, this is going to be BC over 3. Okay. It will be BC over 3. So we need AB. So DC should be BC over 3. Okay. So now I need BC. BC. I think I've used it in the other diagram. So BC in the previous calculation. So I said BC over sine 2x. So it's 30 degrees. equals, I'm going to go with the sine rule to pick this angle up, and I will get CD in this case, CE. Just think about this quickly. Okay, so this is going to be unnecessary, eh? So we know that DC is going to be BC over 3. So what I do is cross multiply, so therefore BC is going to be 3DC. Okay? So there I got BC. Now DC, so therefore the area is going to be BC times, sorry, not BC, coming straight from here, no? It's going to be DC times BC, which is 3DC, which gives you 3DC squared. But remember, they want AB squared. So DC is equal to, so you say since DC is equal to AB. Why? So no reason required, but just writing it in here. Opposite sides of a rectangle are equal. Okay, so therefore the area is going to be 3 AB squared. Okay, which now proves what they wanted you to prove there for 3 marks. Okay. So that brings us now to question 8.